Hey everybody, welcome to another episode of the Subnet Show. I am your host, Gabriel Cardona. Connor has the evening off so he can spend some time with his wonderful fiance. So it is just you and me. I bet you thought you were going to get rid of me, but no. It's not that easy. You still got me this week. So since I had some time alone, I thought, what can I do? I want to make sure and not drop the ball. We need to, of course, ship a new episode of the Subnet Show, and there's tons to talk about. And so I decided that I would give my Avalanche Developer Toolkit presentation. It's a presentation I've given now, I think 2, maybe 3 times. And I thought this is a good opportunity for me to go ahead and give it and document it on the Subnet Show. And so that's what I'm going to do now. So give me 1 second to set this up. I'm going to share my screen, which you should be able to see now. All right. So today we're going to be giving the high-level overview of the Avalanche Developer Toolkit. This will basically include all the different libraries and services which are available in the Avalanche developer ecosystem. So a brief introduction, who am I? My name is Gabriel Cardona, and I am developer evangelist from Ava Labs. And it is my incredibly cool job to go around to different hackathons and meetups and conferences and conventions. And I give presentations with the intention of inspiring people to build amazing dApps on Avalanche. And why do I do this? Why do I spend so much time doing this? Why am I so passionate about what I do? I genuinely believe that the most valuable asset on the entire planet at this exact moment in time is a competent, hardworking, and creative developer. And so I believe that if we were to zoom way out and take the 10,000-foot view of where we're at in the evolution of our species, I would say that we are just now beginning to see a small glimmer of the promise and the potential of humanity. We are capable of so very much. However, we have big problems and we need to scale them. We need to solve them at scale and velocity. Fortunately for us, there have been so many paradigm shifts in computer science and engineering over the last couple hundred years. So if you go back to, I like to go back to Ada Lovelace and Charles Babbage and the difference engine and the analytical engine. These were like Victorian era steampunk computers. They were the size of buildings that had big cranks and gears and steam. And these were the very first computers. And if you go back then till now, we have had just so many breakthroughs in engineering and computer science that we have a toolkit which is unlike any time in all of human history. And so now what we need are competent, creative, and hardworking people to step forward and build the systems which solve the problems. So that's why I believe that engineers and developers are so incredibly valuable. And I've said this before, and I'm sure I'll say it again. There has never been a greater time in all of human history to have a big idea, to find a like-minded group of people and raise capital to build and launch a game-changing app and change the world and make a fortune. The amount of capital, both human capital and actual financial capital, the amount of capital required to launch a startup has just been rapidly decreasing. And so what 10 years ago may have cost you $1 million to launch, and some of the APIs weren't even around then. So even if you had the $1 million, you didn't have access to, smart contracts and some of the blockchain technology we have today, some of the deep learning technology, the Internet of Things, so many technologies. Even if you had the money 10 years ago, they weren't even available. But for the sake of argument, what may have cost, $1 million 10 years ago and $100,000 5 years ago, you can now launch that same minimum viable product, that same idea, that same startup for, tens of thousands of dollars. And it's because the software stacks we use, the libraries and the APIs, they are so powerful now, so high level. The economy of the expression is so great and so powerful that it requires less engineers to write and maintain the systems. And in addition to that, the platforms that we all use, the cloud services, again, the libraries and the frameworks, they're nearly all either open source, in which case they are both free, libre, and gratis, like free as in speech and free as in pizza, or they at least have a free tier. So you can, launch on your free tier like Heroku or Morales, and then you can scale up to a paid tier whenever you need it. This has just brought the cost of shipping an MVP, a minimum viable product, way, 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 way down. A couple more reasons why there's never been a better idea to do this. Web3 has built into it as a native primitive value, right? Like it's in vogue today to raise capital via a token sale or to do something like yield farming. That's expected. And in addition to that, there are so many successful blockchain entrepreneurs and investors. So we consider Avalanche to be blockchain 3.0 technology, which kind of implies there's been blockchain 1.0, which was Bitcoin, and blockchain 2.0, which we think of as Ethereum. There have been many successful entrepreneurs from the blockchain 1.0 and the blockchain 2.0 eras who have had liquidity events, who have made money and are now looking to put that money to work for them in the form of an investment. And that's another reason that's very, very possible to raise money these days. And so the story that I like to tell to kind of illustrate this point is when I was at Trulia in 2012, we had an initial public offering and we went public on the New York Stock Exchange. And our CEO, Pete Flint, who's an amazing entrepreneur, had to do a roadshow all around the United States where he literally physically traveled to like 8 different cities across the US, and he had to, press the flesh and wine and dine all of these big wigs to get everybody on board. We had to hire a whole team of, we're in Silicon Valley, so Silicon Valley financial lawyers. There were 4 or 5 of them, plus all of their hangers on. It took about 13 months to complete. It was wrapped in red tape. It was very, very challenging and expensive to do. When we went public, Pete got to actually go to the New York Stock Exchange and ring the bell in the morning. That was pretty rad. And then we raised $102 million during the IPO. That's how much capital we raised. Now compare that with creating a token on our C chain and launching an ICO or an IDO. You could raise $100 million in one afternoon now. The pace at which capital moves in Web3 is genuinely shocking sometimes. And then the very, very last reason why it's a great time to do this is that everybody in the world is just super wired in right now, and ideas spread globally nearly instantly. So the amount of time between the introduction of a new technology and how long it takes to go mainstream is decreasing. So we're going to continue to see amazing ideas catch on and spread like wildfire. That's why it's such a great idea and a great time. Okay. So now let's actually dig into some of the technology for the Avalanche developers. So we want to start with Avalanche Go, right? Avalanche Go is the reference implementation of an Avalanche full node. And as you might imagine, of course, it is written in Go, and it contains the full breadth of functionality which is available on the Avalanche platform, including the primary subnet, which consists of the X chain, the P chain, and the C chain. And there is a JSON RPC for each chain. So, with Avalanche Go, you can create variable and fixed cap SecP 256K1 assets. You can obviously create non-fungible tokens. You can stake your AVAX and have your node be a validator. So when your node is a validator, it's a full block and vertex producing node. And then, of course, you get rewarded. You can also delegate if you don't want to run your own full node. If you don't want to take on that responsibility, you can delegate your AVAX to a full node, and it actually increases their sampling weight. You can create a new subnet. You can add validators to your subnet. You can instantiate virtual machines as blockchains on your subnet. You can swap assets back and forth across the different blockchains. So as I mentioned, we have 3 blockchains on our default subnet, a P chain, a C chain, and an X chain. You can actually swap the assets back and forth. There is also a key store API, which enables you to store your keys on the full node. Now, I want to point out that we consider this to be an anti-pattern, and we recommend that you do not store your keys on the full node and that you instead use something like a mnemonic, which is a human readable string that encapsulates entropy, and that from that mnemonic, you can deterministically derive a hierarchical tree structure of different keys. And then you can create and sign transactions locally using something like Avalanche JS. That's what we recommend instead of having your keys on the machine. If you have your keys on the machine, it just makes it a target for a malicious actor. And the other one, going from mnemonic to HD keys and signing with Avalanche JS, is the proper way to do it. Another thing to note is if you're familiar, if you're like on a Unix box and you know a tilde is your home directory, and then if you put a dot at the beginning of a directory name, it makes it hidden. So there is a hidden directory called .AvalancheGo, and it lives in your home directory. So tilde/.AvalancheGo is the path. In that .AvalancheGo directory, you will find a staking directory. And inside that staking directory, you will find both a TLS certificate and a private key. So Avalanche uses transport layer security, or TLS, to protect node-to-node communication from eavesdropping. TLS combines the practicality of public key cryptography with the efficiency of symmetric key cryptography. And this has resulted in TLS becoming the standard for internet communication. So whereas most classical consensus protocols employ public key cryptography to prove receipt of messages to third parties, the novel Snow consensus family does not require such proofs. So this enables Avalanche to employ TLS in authenticating stakers, and it eliminates the need for costly public key cryptography for signing network messages. We have TLS certificates. So, Avalanche does not rely on any centralized third parties. And in particular, it does not use certificates issued by third-party authenticators. All certificates used within the network layer to identify endpoints are self-signed. And this creates a self-sovereign identity layer with no third parties ever involved. We also have TLS addresses. To avoid posting the full TLS certificate to the platform chain, the certificate is first hashed. And for consistency, Avalanche employs the same hashing mechanism for the TLS certificate as what is used in Bitcoin. So namely, the DER representation of the certificate is hashed with SHA-256, and the result is then hashed with RIPE-MD160, which gives us a 20-byte identifier of the stakers. And the 20-byte identifier is actually represented by the string node ID dash followed by the data's CB58 encoded string. So you might be asking, what in the heck is CB58? If you're familiar with Bitcoin, you're familiar with base 58 check. So base 58 check is a base 58 encoding with a checksum. We have what's called CB58, and CB58 is also a base 58 check encoding with a base 58 encoding with a checksum. It is, however, confusingly slightly different than base 58 check. CB58 only SHA-256 one time instead of twice, and we use the first 4 bytes for the checksum instead of the last 4 bytes, which is what base 58 check does. So don't ask me why it's like that. I wasn't around when it was introduced to the platform, or else I would have just lobbied for us to use base 58 check. Why would we have to reinvent that? I'm not sure. It's definitely been a source of confusion for pretty much every team which I have been on ramping that have actually been working at a low enough level to be doing transaction serializations with checksums. I've had multiple people come back to me and be like, I think your base 58 encoding is broken. And I'm like, no, it's not broken. It's just not base 58 check. It's CB58. So anyway, if you see CB58, it's not a mystery. It's a base 58 encoding with a checksum. We use it extensively throughout. We use hex and CB58. Those are the 2 primary encodings that you'll see. And buffers are obviously as well. So regarding other full nodes, currently Avalanche Go is the only full node implementation on the Avalanche network. And our intention, of course, is for there to be a very rich and diverse ecosystem of full nodes. So an analogy that I like to use is the web and the different web browsers. So, story time, back in the day on the web, there were really 2 big browsers. There was Netscape Navigator and Internet Explorer. And at the time, there were no web standards. So there was no DOM API, there was no HTML spec, there was no CSS spec. So they would actually reverse engineer each other's functionality. And poor early web developers, not only did they have like a very, very early version of JavaScript, which was very, very rough, they also had to do things like try and suss out what browser they were dealing with based on a user agent string. And then they would build out, a JavaScript app that was if-else statements that basically served up different parts of the app depending on what browser you were in. Or you may remember this, if you were on the web back in the day, there would be little pictures at the top of each web page that said, a little banner that says, this website runs best in Internet Explorer, or this website runs best in Netscape Navigator. It was really, really a bad situation. Now compare that with the web we have today. Today, we have the World Wide Web Consortium created by Tim Berners-Lee, the gentleman who created the web. It's a standards organization. We have the DOM API. We have HTML5, the living document, or HTML, the living specification. We have CSS. We have ECMAScript. We have everything spec'd out. And then we have all the major the browser vendors. We have Safari, of course. We have Chrome, Internet Explorer, and Edge. We have Opera. Did I say Firefox? We have all of the, and then the long tail of people who are just using Blink or WebKit. There's mobile browsers, there's browsers, you know, the web is totally ubiquitous. And the reason that's possible, JavaScript really ended up fulfilling the destiny of Java. Java was supposed to be write once and run anywhere, but that's really the web, right? You write your web app, you can run this thing, darn thing anywhere. It'll run on a watch, it'll run on a TV, it'll run on a toaster. I wouldn't be surprised, you know, if it's running on the friggin' space station. Like the web is absolutely ubiquitous. And so we got that because we have a standards body and we have multiple implementations with the different browsers, and the different browsers help suss out the edge cases and the bugs in the specification. And you might ask yourself, why would you need multiple browsers, right? If they're just rendering the same, they're implementing the same specification. But you know, it's like the difference between running Chrome and running Safari. They just have different user experiences and they offer different features in the way they plug into their own particular ecosystem. And then in addition to that, they also implement, you know, they have a rendering engine for HTML and CSS, right? So it's the same thing. We hope in the future there will be a formal, you know, some type of Avalanche specification, and then there will be multiple full nodes that implement it. And then they all bring their own special sauce to the table as well. So next we have the local network runner. And this is for firing up a local test or private network for development. And this is very akin to Ganache from Ethereum, if you're familiar with that tool. We have the local network runner, which is a tool to run and interact with an Avalanche network. Now, I can hear some of you out there saying, but what about Avalanche? Yes, I also thought the same thing. Don't worry. That's very perceptive of you. So Avalanche has officially been sunset, and the LNR is the path forward. So, you know, just so you know what's up, Avalanche was actually created before mainnet went live, right? So that seems like, you know, the dawn of history, how fast things are moving. But yes, you know, Avalanche was created and architected before the mainnet, and it was actually created and architected by an intern. And to be fair, is a very, very good engineer, and he actually went on, he's at Google now. But the point is, just so much stuff has changed that we had already been discussing doing a complete rewrite of Avalanche from the ground up, and that's basically what happened, except now it's called the local network runner. And so it's similar to Avalanche, you know, I'm going to call it the LNR. So similar to Avalanche, the LNR is a tool to run and interact with an Avalanche network. The nodes that compose the network can run either locally or they can run in a Kubernetes cluster. And when you run it locally, each node runs in a process on your computer. And in Kubernetes, each node runs in a Kubernetes pod, and the Kubernetes pods may be on your computer or they may be remote. For configuration, using the LNR, when you create a network, you specify the configurations of the node that are in the network upon creation. And not only properties such as the node's name and staking cert or key are configurable, but also configuration which is specific to the type of network runner being used. So for example, a node running in a Kubernetes cluster has a config field that specifies the Docker image that the node runs, whereas a node running locally has a config field that specifies the path of the binary that the node runs in. And you can create a custom Genesis, and this enables configuration of balances and airdrops and reward addresses, and you can even add in your own custom Genesis text. So, you know, like in the Genesis block of Avalanche, we have from Snowflake to Avalanche and through consensus to the stars. That's where I got that saying from. It's actually in the blockchain. You can do the same thing here. You can create your own custom Genesis block. You can have balances. You can set up reward addresses. There's also the local network runner implementation includes a predefined configuration, which allows you to create a new network without needing to define any configurations. And this is how you can quickly spin up a 5-node staking network with a pre-funded well address, which is similar to Avalanche. So if you used Avalanche, you know that there was a Lua script called 5-node staking, and that 5-node staking spun up a 5-node network that obviously was a staking network, and it had a pre-funded well address on there. So, you know, you had 300 million AVAX or something like that. And it was everything you needed to start testing, building and testing on an actual 5-node network, but running privately on your machine. The LNR has something similar. It's called the default network, and it does the exact same thing. Fires up a 5-node staking network and gives you a pre-funded well address. So the exact same functionality exists. The LNR lets you interact at both the network level and the node level. Okay, so you can query at the network level, you can start and stop networks, you can get the health of the network, you can add and remove nodes, you can get node names, but you can also drill down to a specific node and get the node's ID, you can get its name, and you can even get a client for making API calls from the individual nodes. So you can interact at the network level, you can interact at the individual node level. And as an example of how to use the LNR, we included a main.go file that uses the local implementation of the network runner. And when you run it, it creates a local 5-node Avalanche network and waits for all the nodes to become healthy. It then prints the names of the nodes. It prints the node ID of an individual node. It spins up a new node, so there's 6 now, and it removes one of the original 5 and swaps in the new one you built. So it kind of just is an example script that shows you how to create a 5-node network, check if it's healthy, query it to get the names, to get the node IDs, to create a new one, to remove one, to replace one. It's kind of the general functionality that you would need. And so you can, of course, take that and expand on it. And this network will run until the user provides a SIGINT or a SIG term. So, we have this built as an example right now in the LNR. Next, we have our Postman collection. So Postman is a platform for building and using APIs. It simplifies each step of the API lifecycle and streamlines collaboration so you can create better APIs faster. So if you're building REST APIs, if you're working on the modern web and you're not using Postman in your workflow, then I highly, highly recommend that you spend the time required to on-ramp your skills into Postman. It's not long, it's an hour or two, it's an afternoon, it's an evening. But just one day when you start, say, okay, today I'm going to on-ramp into Postman. That's my goal. And just make it part of your workflow that day. If it slows you down, that's okay, because in the end, it's going to accelerate you so much faster that whatever you lose in the amount of time it takes to on-ramp, I promise you will gain on the other end with the acceleration. Some things that Postman can do, I believe you should be able to see this. I'm going to jump over on my screen. Hopefully you see this. Postman has environments. So I have one open right here. I have my localhost environment, and you can see these are just key value pairs, right? So I have protocol is equal to HTTP, host is equal to avalanche.network.local, port is equal to 9650. You can see I have a password here, and you might be thinking, well, shoots, Gabriel, you just showed me a password. That's okay in this particular case because this is my local host environment. So obviously these are just going to be things I'm using on localhost. I have a mainnet environment, and in it I have some sensitive password material, but you're not going to see that, right? So I'm not being compromised at this moment. But you can see, so note it's protocol HTTP. These are environments. If you jump over to an actual request, here's where you see the environment variables being used, right? So you can see right here is protocol, and it shows you what it is right here. It actually populates it with the values from the environments file. It also has code snippets. So over here on the right, if I click on this code symbol, it opens up this side window, side UI element, and it's got this curl request. And so you can do different formats. I just have curl because I like to copy this and paste it over to my terminal if I need to. It also has documentation. So if I close this up here, it says documentation. I actually added this, given a blockchain's alias, get its ID. You can see right here, you can edit it. I even put the URL and it links out to our actual docs, which is pretty rad. Not only does it have documentation, it has the post values, so you can change the post body over here. You can see right now I'm getting the blockchain ID on the mainnet of the X chain, and you can see here's the answer. But if I change it, I could also say, what's the blockchain ID of the P chain? And boom, it changed down here. You can see it. You can change the request and the response type. So if you guys are familiar with the way REST works, representational state transfer, you're actually mapping the HTTP verbs to the CRUD operations of a database, right? So you have CRUD, create, read, update, delete. So create maps to post, read maps to get, update maps to put or push, put or patch, and delete maps to delete. And so you can actually map HTTP verbs to CRUD operations, and that's what's called REST. And it's a very, very cool paradigm. It's the modern web paradigm, really. So you can actually change the HTTP verb up here. You can also get the HTTP response. So, like a 200, a 404, a 500. You also get the time, and it breaks it down to all the different parts, including the TCP handshake, the SSL handshake, etc. And you get the size of the response body. And there's so much more. Postman is absolutely amazing. Again, I use it every single day. It's always open. I highly, highly, highly recommend that you take the time to on-ramp into that skill. All right. Back to the slideshow. Documentation. So, sort of, we understand that the canonical answer to any question regarding how Avalanche works is read the manual, right? It's such a cliche, it's a joke, right? Read the manual, read the manual. So with that in mind, we have exhaustive and up-to-date documentation. Of course, it's open source and it's written in Markdown. Markdown is incredibly simple to learn. And so we actually encourage everybody at AvaLabs, even non-engineers, we encourage them to, if they want to contribute to the documentation, that they're welcome to, and they can just fork the repo and start messing around in Markdown and make changes. This is a living document, and it is the canonical source of truth for our entire ecosystem, and we want to keep it up to date. So if you see something which is out of date, or if you see that it can be improved in some way, we absolutely encourage you to fork the repo, make the change, and create the pull request. I am of the opinion, and it has been my experience, that updating documentation remains the single easiest way to contribute to an open source project. It's a really, really great way to connect with a team, and you can help move the ball forward for the entire project while you build up social equity with the team. And so, speaking firsthand, having created so many open source libraries in my career, I just have a very, very genuine appreciation of the importance of quality documentation. And so on my very first week on the job at AvaLabs, I immediately started improving the docs. I found errors, or I found stuff that was out of date, and I fixed it. I added brand new tutorials. I ran the entire code base through a Markdown linter, and I made a bunch of changes, stylistic changes. I even alphabetized JSON RPC calls at one point. Like, I was really, really going out of my way to make the docs very, very nice. And so eventually Dan Lane, who's one of our amazing engineers on the frameworks team now, he used to be on the platform, he was the primary owner of the repo, the docs repo, and he was just like, look, dude, give Gabriel editor permissions on the docs repo. He obviously cares, right? And so, again, like, just my own personal experience, the single easiest way to contribute to an open source project is to help with the documentation. It is an absolute great way to connect with the team. It's a great way to learn about the project. It's a great way to move the project forward and to build social equity with the people on the team. Our docs have release notes on Avalanche Go. They also have the Avalanche Notify service, which monitors all validators on the network and sends an email alert to a validator's subscribers if it becomes unresponsive or is out of date. So why is this important? So this is important because an unresponsive validator risks losing its potential staking rewards if their observed uptime is less than 80%. So just for super clarity, Avalanche does not have slashing. So a validator's stake is never, ever a risk. It's only their potential staking rewards which are at risk. And of course, the docs have many, many tutorials. You can run, back up, and restore a node, create a multi-node local test network. You can create and transfer fungible and non-fungible tokens. Of course, you can run smart contracts. And our intention is to have tutorials for all of the functionality on the network. And we have started scaling up the developer relations squad, which is the squad I'm the lead on. And our most recent new team member, who just joined a couple of weeks, if you're seeing this, what's up, Raj? We just had a new team member named Raj Ranjan from India. He was actually the winner of a recent competition to have to create tutorials. You may remember a few months ago, we had a $50,000 prize pool to help improve our documentation and tutorials. And I believe he won 3, possibly 4 of those. He really performed well. And so we reached out to the dude and asked if he wanted to be on our team. It's pretty cool. And so the quality and quantity of our documentation is going to be improving really, really rapidly this year. It's a primary focus for our developers relations squad, and we're actually bringing on people specifically for that task. And so speaking of which, I'll drop the alpha. We're hiring one more role for the developer relations squad. That's the squad I run. So if you want to work on my particular squad, we're trying to find somebody. It's a developer relations role. You would be a developer evangelist like I am. Ideally, you would be a technical writer. So, if you're listening, if the stuff I'm talking about today turns you on and your brain is like, yes, hit me up. I'll share my contacts at the end. So, stick around. The docs have the JSON RPC for the XP and C chain, and we do not document the entire EVM JSON RPC simply because it's documented elsewhere, for example, on the Geth documentation. So for the EVM, we only document Avalanche specific JSON RPCs, such as avox.getAtomicUTXO and avox.import avox for doing cross-chain swaps. There are several Avalanche specific RPCs, but just have an awareness that if you go look at our EVM docs and you're expecting to see all of the Geth related stuff, the EVM related stuff, it's documented elsewhere. And then we also have documented the serialization specifications. So you remember Avalanche has virtual machines. A virtual machine is the application level logic of your blockchain. But technically speaking, a virtual machine is a state machine. So you have the state of your blockchain, and then you have a state transition function. And you can trigger the state transition function with transactions. And so we have different transaction serializations. There's base transaction for sending tokens around. There is create asset transaction for creating new tokens and new non-fungible tokens. There's operation transaction for minting minting tokens. There is import and export transaction. There's add subnet validator transaction, add delegator transaction, add validator transaction, create chain transaction. And I don't think I've missed any. So this is on the Avalanche virtual machine. There's all these different serializations, and also on the platform VM as well. So we have those serializations spec'd out in the documentation. So if you were to create your own library, for example, you would be using these serialization specs in order to create the transactions, which ultimately trigger the state transition functions on the different blockchains. We also have our white papers. We have the platform white paper, the consensus white paper. We have the token white paper up there. There's even a classification framework for stablecoin designs. It's a pretty interesting read. I suggest checking that one out. And we also have some of our audits. So we weren't able to put up all of our audits, but we have some of our audits up there. That's worth checking out. And then, of course, we realize that the blockchain is worldwide and that not everybody in the world speaks English, obviously. So a big focus is on internationalization. And we have French, Japanese, Turkish, Spanish, and Chinese simplified in the works now. There are already pull requests. We're just ironing out the, basically integrating them. And then in the future, we want to have even more languages. So that's a focus of ours is, of course, internationalization. Next, we have Avalanche JS, which of course is near and dear to my own heart because that's the library that I personally maintain. And it is a TypeScript library for interfacing with the Avalanche platform. And it's built using TypeScript, and I'm a huge advocate of TypeScript. And if web tech touches your workflow, and I suspect that web tech touches nearly everybody's workflow, then you must take the time and on-ramp your skills from JavaScript to TypeScript. This is something that absolutely must happen. So let me give you my elevator pitch on why TypeScript, okay? So here we go. So over the history of programming languages, we have seen two patterns repeat over and over. We've continuously gone from programming in the small to programming in the large, and we've continuously gone from programming with low-level abstractions to programming with high-level abstractions. And you can be sure that whatever we consider super high-level and super huge today will be thought of as low-level and small by the next generation of engineers. So why do we keep seeing this pattern? Basically, we are living during perhaps the most unique phenomenon in the history of the universe, and I'm not overselling it here. We are living during this exponential growth in the power of computation in digital systems. So colloquially, we all call this Moore's Law. In popular culture, this is known as Moore's Law. But if you're a computer scientist or an engineer, of course, you realize that Moore's Law is related to fitting transistors on an integrated circuit. and that there is in fact only so much progress we can make there, right? Everybody keeps saying Moore's law is dead. Why? Because the scales are so small now. We're at the nanometer scale, and we're literally running into quantum tunneling. We are literally running up against the walls of what is possible with the physics of our universe. Now, it's entirely possible we'll start building our chips into the third dimension. Our brains are in 3D after all. We might go to quantum computing. We might use clever algorithms. We might go to parallel computing instead of just getting faster. But there's many different ways we're going to continue to have accelerated the pace of change. And so, as all of this technological change is happening, it's adding more and more complexity that we as system designers have to tame. So let me get back on track here. So think about all of this complexity is like a sphere, right? Visualize a sphere with me. And that represents the problem space, okay? And it's growing in all dimensions exponentially, right? So it's just the sphere that keeps getting bigger, bigger, and bigger. It is our job as systems designers to always have a solution space that is at least large enough to encapsulate the complexity or the problem space. So if the problem space is a sphere, picture a cube that is just big enough to encapsulate the sphere, right? The cube is the solution space. The sphere is the problem space. At any moment, the complexity could grow by orders of magnitude, right? So at any moment, this sphere can absolutely blow up. So it's on us to ensure that we always have, the tooling required to tame the growing complexity. And that's why we witnessed the two patterns I mentioned about languages going from low to high and code bases going from small to large, because it's always the same phenomenon of more and more and more and more complexity happening and needing to go higher and higher and higher and bigger and bigger and bigger with our APIs and our code bases in order to continuously tame the complexity. So to bring it back to TypeScript, JavaScript was literally created in 10 days. I don't know if you're totally aware of that, but it's actually quite true. JavaScript, the language, was created in 10 days back in the mid-90s. So, at the time, nobody envisioned that the web would be as ubiquitous as it is today. I'm sure the most visionary person back then probably didn't really appreciate that the web would become absolutely ubiquitous. So, since JavaScript is the object-oriented scripting language, which is bundled with the web, all of a sudden it became everybody's problem. Everybody on earth, if you're an engineer, all of a sudden JavaScript is your problem. So there has been a renaissance in JavaScript over the last 12 years or so, starting with Node.js until now, to make JavaScript more and more palatable. And it really has culminated in TypeScript. So TypeScript was created by Microsoft with the intention of being JavaScript for programming in the large. I like to think about it as JavaScript 2.0. And so TypeScript gives you the additional APIs to really express your abstractions so clear that they don't buckle under their own weight. And it brings your IDE to life with IntelliSense. You get code completion, parameter info, quick info, error detection, member lists. TypeScript can catch errors at compile time instead of runtime, and there's so much more. So, that's my pitch on TypeScript. You can tell I care about it, but that's because I care about quality software, especially in the context of value-bearing crypto assets. And so if you want to work on my team, you will be using TypeScript. And if you ever hand me any code to review, I will literally refactor it from JavaScript to TypeScript and hand it back to you. TypeScript has just been so incredibly valuable to my personal web development skills that it is a one-way door, and I am just unable to walk back through it. Now, back on track with Avalanche JS. Avalanche JS is written in TypeScript, and it is isomorphic, which means that it runs both on the client or the browser as well as the server in Node.js, and it lets you issue commands to the Avalanche Go full node APIs. So currently the APIs which are supported are admin, auth, health, index, info, key store, metrics, socket. We have a WebSocket API, and then there's the AVM API, the EVM API, and the platform VM API, in addition to any custom subnets and virtual machines. And, Avalanche JS is really a very high quality code base. We really have put some serious love into this. Obviously, extensive use of TypeScript. We use classes, we use interfaces. There are types on all variables and return values. We use async and await instead of promises or .then. We use import statements instead of require. We use const and let instead of var. So, we use all the good things. We use fat arrow functions. I think there's over 80% test coverage, and we request that anytime anybody creates a pull request that they include corresponding documentation and test coverage. And so using Avalanche JS, developers can locally manage private keys, retrieve balances on addresses, get UTXO for addresses, build in signed transactions locally, issue signed transactions to the X chain, the P chain, or the C chain on the primary network. You can create a subnet, swap AVAX and assets between the X chain, the P chain, and the C chain. You can add a validator to the primary network, add a delegator to the primary network. You can administer a local node, including getting metrics and health checks from it. You can retrieve Avalanche network information from a node. You can create BIP39 compliant mnemonics in 8 different languages, and you can have from 128 bits to 256 bits of entropy. You can create BIP32 and BIP44 compliant HD nodes. So as I said, you can go from mnemonic, which is a human readable string, which represents a source of entropy, either 128 to 256 bits. You can then you can deterministically derive a hierarchical tree structure of ECDSA key pairs. It's really, really super rad. This is all with Avalanche JS. We also have the WalletSDK. So the Avalanche WalletSDK is a TypeScript library for creating and managing non-custodial wallets on the Avalanche network. It provides high-level methods for transacting on the X chain, the P chain, and the C chain. There are 4 types of wallets that are supported in the WalletSDK. There are singleton wallets. So this is like a single SecP256K1 curve on an ECDSA key pair. There's ledger wallets, so you can connect the WalletSDK with the ledger hardware wallet, incredibly useful. You can do mnemonics and HD wallets. So as I mentioned, going from a human readable string representing entropy to deterministically deriving a tree structure of key pairs. You can do extended wallets. So it's XPub and there's also XPrib. So an extended key is like the root of a branch in the tree of an HD wallet. And with the root of the branch, you can derive the rest of the branch. So using the Avalanche WalletSDK, developers can receive and send tokens and NFTs, transfer funds between chains, add a node to the validator set, delegate stake to a validator, create key store files from the wallet instances, get the transaction history of a wallet, mint NFTs on the X chain, and more. One of the reasons for Avalanche's meteoric rise in the last year has been that our C chain is 100% backwards compatible with existing EVM developer and tooling and workflows. And so devs just need to add Avalanche as a new network and to their existing workflow, and things just work out of the box. And so you can see on the left here, I have Open Zeppelin, Truffle, framework, Hard Hat, we have Remix, MetaMask, any tooling that you're using right now to deploy to any EVM network. All you have to do is add Avalanche as a new network. And you can see here, I have the mainnet, Fuji, and local testnet configuration here, you know, the chain ID, the RPC URL, etc. So you can plug this information into Hard Hat, plug this into Truffle, plug this into Remix, plug this into MetaMask, and you automatically connect to the Avalanche network. We also have a smart contract quick start. So the goal of the smart contract quick start was to lay out best practices regarding writing, testing, and deploying smart contracts on the Avalanche C chain. And we build the smart contracts with the development environment Hard Hat. We use Hard Hat internally as opposed to Truffle. So we used Hard Hat for the smart contract quick start, but I think Truffle is amazing. Truffle was the first tool I learned in Ethereum years ago. And I remember it blew my mind. It was the best at the time. It was the best crypto framework I had seen. JavaScript framework I had seen. I genuinely was floored the first time I used Truffle. I remember it was like a true eye opener for me. And so I still have a lot of love for Truffle, but we actually like Hard Hat better. So we used Hard Hat here. And so this repo gives you the basic workflow for writing, testing, and deploying smart contracts. And included is an ERC20, which is a fungible token, and an ERC721, which is a non-fungible token contract. And they both extend Open Zeppelin contracts. So, you know, Open Zeppelin is a great company. They have a bunch of battle tested and peer reviewed and security audited contracts, which are industry standard. And using object-oriented, methods, we're able to extend them and inherit all their functionalities. So that's what the ERC70, 721 and ERC20 examples are. We also have a storage smart contract, which is just a very, very simple example showing how to write and read a small bit of data to and from the blockchain. So that's also very handy. Virtual machines. So as you probably know, and I've mentioned it before, Avalanche isn't just a single blockchain. It's a network of subnets and blockchains, and each subnet will ultimately be its own paradigm. It'll have its own specific tooling and companies and style. Like you might have a gaming subnet or an IoT subnet or a privacy subnet or a traditional finance subnet. And so there's been subnets which have started launching now. There's been a couple that have recently launched, and one of them is called Spaces. So Spaces is an authenticated hierarchical key value store with EIP 712 compatibility, state expiry, and fee-based metering. And that's Spaces VM. And there is tooling around creating subnets, and that includes AvaSim. So AvaSim makes it easy for anyone to spin up a local instance of an Avalanche network and interact with the standard APIs or to test a custom VM. So if you've got a custom VM and you want to test it out, you should use AvaSim. Subnet EVM is the virtual machine that defines the subnet contract chain. So Subnet EVM is a simplified version of the Cori of this C chain. And this chain implements the Ethereum virtual machine and supports Solidity smart contracts as well as most other Ethereum client functionality. So something that's incredibly popular is teams will launch their own EVM layer 1. It's still happening today. I'm sure literally today, somebody somewhere launched their own EVM layer 1. And that's incredibly awesome. We did the same thing, right? We got the C chain. So I understand. What I would suggest going forward, though, is instead of launching it on your own into a bespoke network that's very hard to get network effects on, launch your layer 1 EVM as a subnet on Avalanche, and you get all of the goodness out of the box. You get Avalanche consensus, so you get thousands of transactions per second. You get cross subnet asset transfers when they go live, so you'll have access to all of the liquidity in our C chain, the billions and billions of dollars of liquidity. You'll have access to it. You'll have access to all of the users because you can do cross subnet asset transfers. So there's this network effect and this compound network effect that's going to happen. So this is a really big one, this subnet EVM. The ability to launch instances of the EVM on an Avalanche subnet now, all you do is define a JSON config file. It's that simple. So you can imagine a startup that actually has as a service like an EVM testing framework where they just spin up an instance of the EVM and run individual tests so they can be sure they're super granular and clean. And it's going to be very exciting to see what people do with this. We have the timestamp VM. So this defines a blockchain that is a timestamp server. And each block in the blockchain contains this timestamp when it was created, along with a 32-byte piece of data, which we call the payload. And each block's timestamp is after its parent's timestamp. So this is like a proof of existence service. You may have seen on our interview with Goon, where Connor and Goon were talking, and they were saying they created one of the very first Bitcoin dApps ever. And it was like a notary. It was like a proof of existence. It was this exact same idea. So you take a document, you take a hash of the document, you then write that hash to the blockchain. And then later, if you have to prove, no, man, I owned that document, you can take the same document, you can hash it again and compare the hash you get now with the hash that was written to the blockchain back in the past. And you can prove, I am the person who had this document because I have the same hash that was written to the blockchain years ago. It's like a proof of existence thing. So there have been many iterations of it all the way back to Goon and Connor back in 2015. But here we have what's called the timestamp VM, and it's the it says timestamp EVM there. That's a typo. It should say timestamp VM, and that's what I just described, like a proof of existence service. We also have the AVM. So the AVM is the Avalanche Virtual Machine, and this is a DAG chain. So on Avalanche, we support two different data structures with regards to blockchains. We have DAGs, that's a directed acyclic graph. This is a data structure that is partially ordered. It's really good. It's parallelizable, it's prunable. It's best suited for commutative transactions like peer-to-peer payments or simple token transfers. It's UTXO based. and it's extendable via what are called feature extensions. The other data structure we have are called linear chains. They're totally ordered and they're great for smart contracts. Regarding the AVM, it's extendable via feature extensions. So you can, it's very general and you can add more and more functionality. Today, there are 3 feature extensions. The first is SecP 256K1 variable and fixed cap assets. So simple tokens, right? AVAX, the AVAX token, 720 million ever, it's a fixed cap asset. It was actually issued as what is called an ANT, an Avalanche native token, which is what I'm talking about, a SecP 256K1 variable or fixed cap asset on the X chain. The second feature extension is called NFTs, and the third feature extension is called properties. And this allows you to tie key value pairs to individual addresses. But you can imagine in the future having feature extensions like posts or quantum safe crypto or BLS signatures or Schnorr signatures. And, you can imagine plugging in more and more functionality. This is the AVM. And then lastly, we have the create a virtual machine tutorial and the create a subnet tutorial. And as I mentioned, we just hired Raj, and we're hiring one other person on my team to create many, many more tutorials. So keep your eyes open for a bunch of new tutorials coming soon. There is a public API server that allows developers to access the Avalanche Go Avalanche network without having to run a node themselves. So the public API server is actually several Avalanche Go nodes, and they're behind a load balancer to ensure high availability and high request throughput. The public API server is at api.avax.network, and that's mainnet. api.avax-test.network is for testnet or Fuji. And then, of course, to access a particular API, you just append the relevant API endpoint. So, for example, the URL to send Xchain APIs is api.avax.network/ext/bc/x. There's also sticky sessions. So requests to the public API server are distributed by a load balancer to an individual node. So as a result, consecutive requests may go to different nodes, and that can cause issues for some use cases. For example, one node may think a given transaction is accepted, while another node, the transaction is still processing. And to work around this, you can use sticky sessions, and this allows consecutive API calls to be routed to the same node. And you can do this over curl, or you can do this using Avalanche JS. Regarding availability, usage of the public API nodes is free, and it's available to everyone without any authentication or authorization. Rate limiting is in place, but many of the APIs are cached, and the rate limits are really, really quite high. So massive shout out and respect to Patrick, our VP of engineering, and Druba, software engineer. They basically architected this. There might be somebody else who's working with them, but they're the only 2 that I'm aware of that are working on this. But the public API is an absolute beast. I don't know publicly what numbers we're allowed to give out, but I know we are allowed to say that it serves billions and billions and billions of requests. If you could see the number that this thing serves, you would be shocked. I'm actually shocked. It's one of those metrics that gives me insight into how much is really happening on Avalanche. I mean, billions and billions of these requests are being served up. It's really, really humbling and amazing. So again, shout out to Patrick and Druba just on the great work they've done. If your application is actually running up against a rate limit, which I don't believe it, because I don't I don't think any are, but if yours is, you can reach out to us and we can figure out something for you. So if you're hitting the wall, let me know. Okay, so we also have a faucet. So, as a developer, you will definitely need funds to test your dApp, obviously on Fuji. So to get funds, we have what's called a faucet, and a faucet just gives you a drip of AVAX, and you can plug in an X chain address or you can plug in a C chain address, and it'll give you, a drop of AVAX or a drip of AVAX on each respective chain as requested. Now, we do have some rate limiting here because we don't want people just to drain the faucet, and unfortunately, people will do that. So drips are limited to 1 request per hour. So, kind of just make the most of your drip. Don't just like burn it all up immediately. That way you don't find yourself kind of being like, damn, I got to wait an hour. If you find yourself needing a larger amount of testnet AVAX that is practical for you to get drip by drip, please reach out to me. I can, hook you up with whatever you need. When you're developing on your local machine, like if you're using the LNR, or if you were using Avalanche in the past, you would know that there, or maybe you don't know, but you do need to know, there is a private key that we call the EWOC key. And you can see it says EWOC key for local development. EWOQ is just the first four characters in this CB58 encoded private string. So it's just EWOC. It's an easy way to refer to it, but that's just a private key. And it's funded in the Genesis block. So if you remember, you can create a custom Genesis, as I mentioned, and it can do airdrops and reward addresses. And you can do this right here. In that custom Genesis, you can say this private key is funded this amount of AVAX, and it's very, very useful. And you can do what the EWOC, or you can even add your own custom ones. And remember, just remember, these are AVAX on the Fuji testnet and the local network, and these have no monetary values. So, don't get too excited when I say you have 300 million AVAX. Everybody has 300 million AVAX there. They're not valuable. And now wallet, a critical part of any crypto user experience is, of course, a wallet. And it lets you store, send, and receive tokens. You can interact with smart contracts. We have a really, really great web wallet by Emre and team. Shout out to those guys. Our web wallet is, of course, open source. It lets you send on the X or C chain. You can earn by staking your tokens. You can stake or delegate. It enables cross-chain swaps, so you can move AVAX between the X, the P, and the C chain. And there is even an NFT studio for creating non-fungible tokens. You can manage the HD keys, so you can see your past, present, or future derived addresses. And you can even sign a message with a private key to prove ownership of an address, which I think is really rad. So if you have an address and it has a certain amount of AVAX on it and you want to prove that you own it, somebody can come to you and say, here's a random message with a timestamp or something like that, sign it. And you can go sign it and prove to them cryptographically that you are the person who owns the keys behind that certain amount of AVAX. And that's incredibly, incredibly, incredibly powerful. And then we also have explorers. So, an explorer is another critical part of the crypto user experience. It enables you to drill down and to see the historical and real-time data of the blockchain. So you can see blocks, transactions, addresses, you can see smart contracts, all of this in real time. And we have a couple of explorers. We have Snowtrace, which is actually an instance of Etherscan created specifically for the Avalanche C chain. And then we also have the Explorer, which is for the X and the P chains. And then there are also some great non-Ava Labs explorers. So there's a really, really good one by the AvaScan team, and I totally suggest checking it out. And then also I wanted to mention funding. So, we have a few different ways you can get funding in the Avalanche ecosystem. We have an Avalanche X grants program. So this is, straight up for a grant. This is for moonshots. We have Avalanche Rush, which is an incentivization program with the idea being we want to incentivize existing blue chip dApps to migrate from other ecosystems into the Avalanche ecosystem. So we have a fund for that. And then we also have Avalanche Blizzard, and this is an ecosystem and infrastructure round of funding. So we have 3 different ways to get potential funding in the ecosystem, and I suggest checking them out. Okay, so it looks like that is it. Let me stop sharing. Let me jump back over here. All right. Wow. There it is, folks. So I just wanted to give that presentation. Hopefully you got something out of it. If you made it this far, you are an absolute champion. I really just want to express gratitude to everybody out there. I've been having so much fun lately at Ava Labs and working on Avalanche and doing the Subnet show, just at the best time I've ever had. And I'm just meeting so many cool people and learning so much stuff. And it's just a great time. So I just want to express gratitude to everybody who's been a part of the journey. So next week, Connor will be back. We'll be back on track. We've got some really, really great guests lined up. I don't want to give you their names yet because, dates could shift or whatever, but we really have some really cool people lined up over our next few guests. I'm looking very much forward to getting to chat with them about their crypto journey and their visions. So, we will be back next week at the same time. So as we always say, from Snowflake to Avalanche and through consensus to the stars. Thank you so much, everybody.